Hi everyone. In this video I want to continue talking about slope, and I want to talk about how do I find slope if I'm given 2 points. So if we think about lines geometrically, we know that if I draw any 2 points I can connect them with a straight line. So it makes sense that if I have 2 points, that should be enough information that I can get the equation of a line. And as we'll see in future videos, there's a few ways to do that through either slope-intercept form or point-slope form. But for this video, we're just going to talk about slope. How do I get the slope of a line given any 2 points? In a previous video, what we saw was we had a graph and it went through these 2 points. It went through 0, 1, and 3, 3. And so what I did here, I gave us these points again. And what we noticed was the slope of that graph was 2/3. So what we should see here is if I look at just these 2 points, I should be able to come up with a slope of 2/3. What we did graphically is we looked at something, we looked at rise over run. We had this mnemonic where we said our slope was m and it was equal to rise over run. Now if I just have points, this term rise over run doesn't make a whole lot of sense because I don't have the picture that goes along with it. I can't talk about moving up or moving over, but what we saw was the rise over run is really the change in output over the change in input. Okay. So when we look at things with just 2 points, what we do is we have a first point and a second point, and we label our coordinates. So what we do is we have x's for our inputs and y's for our outputs, like this. And I give subscripts to these things. So I'm going to call one of these points the first point. So I'll give these x1, y1, and this will be my second point, so I'll call these x2, y2. Now if I want to look at the change in output over the change in input, what I have to do is look at the difference in my x and y coordinates. So here's our output. We have an output of 3 and we have an output of 1. And now what the difference is, if I go from 3 to 1, that would be a difference of 2. And the way that I look at this analytically is I look at it with subtraction. So if I look at the difference between two numbers, I subtract them and I see what that is. So if I look at y2 minus y1, that's going to be my change in output. What's the difference there? And now if I look at my change in input, I can do something very, very similar. I look at x2. Now I always make sure to start with the same one, x2, and then I subtract whatever I had for x1, like this. So just given 2 points, if I know the 2 points x1, y1, and x2, y2, I can compute my slope with this formula. Change in y over change in x, which is y2 minus y1 over x2 minus x1. So let's go ahead and plug in our values and see what we get. So y2 here was 3 minus y1, which was 1, all divided by x2, which was 3, minus x1, which was 0. Okay, so 3 minus 1 is 2, and 3 minus 0 is 3, which gives me a slope of 2/3, which is exactly what I was expecting. So what I have here, 2/3, matched what I got graphically, was 2/3. All right, so what I'm going to do is I'm going to pause the video. I'm going to put up another example so we can try this again. All right, and we're back. We have our next example here. What we want to do is find the slope of the line connecting these 2 points, -2, 6, and 5 comma negative 2. So I'm going to be quiet for a few seconds so you can pause the video if you want and try this on your own before we go through it. Okay, so now that you've tried it on your own, let's think about this. And we look and say, if I remember what my slope is, well, it's the change in output over the change in input. And so my change in output is y2 minus y1, all divided by x2 minus x1. So we have to go back, and what we're going to do is we're going to label our points. We have to pick a first point and we have to pick a second point, and that gives us our first and second coordinates. So I'm going to call this x1 and I'll call this y1. So this negative 2, 6 will be the first point that I pick, and then 5, negative 2 will be the second point, so I'll call this x2 and I'll call this y2. So I'll try to color code these as we go along. So coming down here, plugging this into our formula, we have y2 is equal to negative 2, and then I subtract y1, which is 6. Then I divide all of this by x2, which is 5, minus x1, which is negative 2. Now, since I'm subtracting a negative, what I'm going to do is I'm going to put this in parentheses. So I can think about this as subtracting a negative, and I know to combine those two. Well, just simplifying here, negative 2 and take away 6, we're going to get negative 8 on top in our numerator. And if we divide, well, 5 take away negative 2, remember, if I'm subtracting a negative number, that turns into addition, and what we often see, or what we often do, is do something like this. The two negatives make positive, so 5 plus 2 on the bottom. In the denominator, we get 7. And so in this case, we see that the slope of the line connecting the 2 points, negative 2, 6, and 5, negative 2, is negative 8/7. So I hope this helps, and in the next videos we're going to continue this, so we'll see more examples of finding slope, and we'll see how we can use both slope-intercept form and point-slope form to find the full equation of lines connecting 2 points.